million years ago or so. So Carboniferous period, it's named after carbon, you know, 'cause that's when you had all the coal measures and all the forest flourish and that back in the day. But a lot was happening at that time, that period of time. You had the deposition of all these sedimentary rocks because of the crust was extending. So the crust was extended because the plates were trying to rip apart, meaning that the whole Midland Valley and around Glasgow and Edinburgh ended up like with loads of magma seeping up through the crust, and you had like eruptions at the surface which spewed out lavas like this. So the reason it sticks out is because everything else around it's been eroded away, and we've been left with these lavas. Like they're a lot harder, they're basaltic in composition, which means that everything else around it, from glacial periods, etc., is just going to end up eroding away. So we're going to go see the Campsies and have a wee look at those today. Basaltic lava in composition, it's dark. That's how you know it's basaltic, it's a mafic igneous rock. Now because it's lava, it means it's an extrusive igneous rock. It came out the ground probably around 1200 degrees Celsius back during the Carboniferous period. Watch what?
That shit.
You can see some of it, it's actually formed some columns here, and the actual lava flow itself, the joints that are running through it. And the reason it's got that orangish brown colour is because it's basically rusting away. Some of the elements that make up those minerals are not happy at the surface, so they tend to rust away. That's what they're doing.
There's something wrong with my camera. Oh, it's the rain.
I forgot my microphone and everything. In the Midland Valley in Scotland, we had a lot of extension going on. You there, come! So the crust was extending, which means it thins out. So when you're like pulling the crust apart, what's going to happen is you're going to get magma seeping up through cracks in the crust. And in this case, we see evidence of that here in the Campsie Hills, right? In the Campsie Glen. So the magmas came up. Sometimes it crystallises in the crust, other times it reaches the surface and it erupts as a lava. Now basaltic lava is going to travel distances. You can see it happening in Iceland today. When you look at a basaltic lava flow, it can go the distance, you know. I was going to start singing a song. I can feel midges.
So they're coming out.
Starting to scratch, itch you.
No, Yura.
Don't you dare. I'm watching you, you better not ruin that shite. So obviously this stuff's not quite as fresh as we'd like it to be, so we're gonna go have a wee look for some fresh stuff so I can show you what we can find in the rocks. This has got a lot of lichen growing on it, which is all the different colours on the front of it, as well as also the rust staining to it, so we need to find a fresh piece so that I can show you what I want to show you here today. So I'm gonna go have a wee hunt, see if we can find some. I wish I brought my hammer.
Oh shit.
Bit of it there. Oh, my legs. Right, so this is a fresh piece of the lava here, and you notice we've got these rectangle crystals in it. Now those are known as phenocrysts. This is a porphyritic texture. Now a porphyritic texture usually forms like it's a two-stage melt like process. Like the crystals that are the bigger ones have obviously had more time to crystallise over geological time, right? And because they've had more time to crystallise, they think this is just like, obviously a theory, they think that they crystallise first, like as the melt's moving through the crust, meaning that they're already crystallised when the lava gets out the surface. Some lovely phenocrysts. Now this rock here as well, like, has vesicles in it. Right, so if you zoom out and notice as well that this rock here has got these holes in it. Hi you there, sit down honey, sit down, sit down, sit down.
You're a
And these vesicles basically represent gases that were in the lava when it erupted at the surface. Like the magma, when it's moving through the crust, obviously it's from the mantle. Like when it reaches like the surface, it's gonna, you know, all these volatiles that are in the magma are released at the surface. So it forms these bubbles, which are known as vesicles or vesicles. I think that's how they pronounce it in America. And sometimes these vesicles or vesicles are filled with different minerals, but in this case we don't see any of them being filled with any other minerals. In this case they are just vesicles still. And you'll notice the porphyritic texture again, like in around the rock. Like this is actually an old quarry. They used to take the stones out and use them back in the day. Do not ask me with regards to dates, but yes, We shall move on. Now I might have to shout at the phone because I forgot my mic and you might not be able to hear me, but if you can't hear me I'll do a voiceover. Or if it sounds bad to me I'll do a voiceover. So this is the main feature of this area. Campsie Hills waterfall, it's absolutely stunning. It's like dripping down over a layer of lava. As per usual, most of the stuff here is lava, but right underneath it at the bottom we do have some sedimentary rocks, which are mudstones and limestones, originally deposited into an ocean, right, a shallow marine area, like, and then the mudstones are deeper marine area, right, so it shows you how the environment was at the time that these lava shear out. So the crystal was spinning, the sea level was going up and down, and during the Carboniferous period we were situated at the equator, so Scotland was at the equator, you know, so the environment was a lot different today. You had like lots and lots of bigger things back then because there was more oxygen in the atmosphere. The reason why there was more oxygen in the atmosphere was because all the carbon dioxide was locked in an ice cap which was situated at the South Pole on top of a continent known as Gondwana. And Gondwana was basically South Africa, or well, Africa and South America joined together back then, right? And that all kind of came northwards eventually to form Pangea and collided with us eventually, right? So basically, carbon named after Carboniferous, you know, Carboniferous named after carbon, which is by a fuck's sake. Carboniferous is named after carbon. The reason it's named after carbon is because you have all the coal measures. The coal measure formations are in amongst these Carboniferous formations, like the Carboniferous and Age Geological formations that you have here in Scotland. Like, so there's Campsies every now and then in between these sedimentary like features, and the sedimentary features, like the sedimentary rocks you see part of the Carboniferous area in Scotland are all like cycles within each other, right? So they all usually like follow the same cycle where the sea level's rising and you have like limestones and mud to the quantity, and the sea level drops and you have sandstones and then terrestrial environments like holes in that forming because you have loads of forestry and stuff. Landscapes were bigger back then, probably had millipedes the size of Eura and dragonflies, like the flying around the size of Eura. You can find that, the evidence for that in the raw pressure, it's absolutely madness. But here, obviously all this was formed recently from like the recent glacial meltwater that's came down and wiped through this gorge. And there's probably been a fault line or something like that, or recircles in the rock, like that it formed like the little dips in the gorge when forming these beautiful stunning waterfalls. You can see a bad of that, like on top here, that waterfall like that lies on and it's coming down like, and it's forming a plunge pool, and then coming down again and forming other waterfalls along the way. So all recent, very recent, probably in the last 10,000 years or so that has been about. And aye, that's it. Dobby's master has given Dobby a spark. Dobby is free.